Yeah, welcome back to next topic. We are going to see LDR. It is another simple topic. This is the second topic in our fifth unit. So LDR, in next session we are going to see fiber optic sensors. It is light dependent resistor. It is a resistance type sensor. A light dependent resistor LDR or a photo resistor or photo cell is a light controlled variable resistor. So the variation, that is the change in resistance, is controlled by light. So that is light dependent resistor. Its resistance changes with light intensity that falls on it. The resistance of a photoresistor decreases with increasing incident light intensity. In other words, it exhibits photoconductivity. The resistance range and the sensitivity of a photoresistor can substantially differ among dissimilar devices. So that is depending on the device or the materials used in manufacturing this. It also plays a major role here. So this is the structure. They are made up of semiconductor materials having a high resistance. Photocells or LDRs are non-linear devices. These are not at all linear. Their sensitivity varies with the wavelength of light incident on them. Some photocells might not at all respond to a certain range of wavelength. So here, this is the basic structure, and this is the symbol for LDR, and this is the metal film contact, and this is the cadmium sulfide track, and it is actually etched on this. This is made in etching process. So working of LDR, LDR works on the principle of photoconductivity. Photoconductivity is an optical phenomenon in which the materials conductivity reduces when light is absorbed by the materials. When light falls, i.e., that is when the photons fall on the devices, the electrons in the valence band of the semiconductor material are excited to the conduction band. These photons in the incident light should have energy greater than the band gap of the semiconductor material to make the electron jump from valence band to the conduction band. When light having enough energy is incident on the device, more and more electrons are excited to the conduction band, which results in a large number of charge carriers. So in the result of this process is more and more current starts flowing, and hence is that the resistance of the devices has decreased, and there is the variation in resistance taking place. Types of LDRs, there are two types. One is intrinsic and another one is extrinsic. There are the intrinsic is the pure. These are pure semiconductor materials such as silicon or germanium. Electrons get excited from valence band to conduction band. So within the material, this is taking place. When photons of enough energy falls on it, the number of charge carriers increases. So photon is nothing but light. So eccentric is these are the semiconductor materials doping with impurities which are called as dopants. These dopants create new energy bands above the valence band which are filled with electrons. Hence this reduces the band gap and less energy is required to in exciting them. So these are faster in response than intrinsic type because of this reason, because of dopants. Characteristics of LDR. So LDRs are light dependent device whose resistance decreases when light falls on them and increase in the dark. So the resistance increases in the dark. When a dependent resistor is kept in dark, its resistance is very high. This resistance is called as dark resistance. So it can be as high as 1012 ohms, and if the device is allowed to absorb light, its resistance will decrease drastically. So when light falls on this material, the LDR, its resistance reduces very drastically. When light is incident on a photocell, it usually takes about 8 to 12 milliseconds for fourth change in the resistance to take place, while it takes seconds for resistance to rise back again to its initial value after removal of the light. This phenomenon is called resistance recovery rate. So this recovery is possible after removing the light, and the resistance here increased on decreasing the light. So resistance increasing, and R where the when you keep increasing the light, the resistance is getting decreased. So that way we can say. So this is dark, this is under daylight, and this is in sunlight. So this is how the LDR works. LDR are less sensitive than photodiodes and phototransistor. A photodiode or a photocell LDR, or a photocell is also known as LDR. Another name to LDR is photocell, are not the same. Photodiodes is a PN junction semiconductor device that converts light to electricity, whereas a photocell is a passive device. There is no PN junction, nor it converts light to electricity. If the light intensity is kept constant, the resistance may still vary significantly due to temperature changes. Extrinsic light depends on resistor are generally designed for longer wavelengths. So this is the LDR. And then construction, if you see, so construction of LDR, modern light dependent resistor are made of lead sulfide, lead selenide, indium antimonide, and most commonly cadmium sulfide and cadmium selenide. These are the most popular materials used in LDRs. A light sensitive material is deposited on an insulating substrate such as ceramic. The material is deposited in zigzag pattern in order to obtain. Next slide, I am going to show you the construction diagram. Obtain the desired resistance and power rating. The zigzag area separates the metal deposited area into two regions. So that I'll show you here. So the disc is then mounted in a glass envelope or encapsulated in transparent plastic to prevent surface contamination. So here this is zigzag pattern, and this is first electrode, and this is the second electrode. Clear coating over the entire top surface. Coating should be done to prevent any contamination. So photoconductive material over the top surface, and cold white contacts, and this is ceramic body, and white terminals are taken here, white terminals. So this is typical construction of LDR. So advantages of LDRs. LDRs are cheap, are readily available in many sizes and shapes. So practical LDRs are available in a variety of sizes and packages styles, and most popular size having the face diameter of roughly 10 millimeter. They needs very small power and voltage for its operation. Disadvantages are they are highly inaccurate with a response time of about 10 or hundreds of milliseconds. So this is the biggest drawback. And applications, if you see, so it can be used as a light sensor, audio compressor, fire alarm, automatic street light. So these are all the applications. So light sensor, the LED lights up when the intensity of the light reaching the LDR resistor is sufficient. So in audio compressors are devices which reduce the gain of audio amplifier when the amplitude of the signal is above set value. This is done to amplify soft sounds while preventing the loud sounds from clipping. Fire alarm. The alarm works by sensing the smoke produced during fire. When there is no smoke, the light from the bulb will be directly falling on the LDR. So automatic street light, it automatically switches on when the night falls and turns off when the sun rises. So this is another very big application of LDR. And there ends the LDR topic. In next topic we are going to see fiber optic sensors in next session, students. We stop here. You can refer AK Ghosh or these books. Stop here. We will meet again in next session. Thank you, students.